All right, I'm doing the second part of the video for the 7.5 chapter review. So we're going to start with number 57. Number 57, here's the equation we have. We have log base 2 of 4x is equal to 5. So what I'm doing here is, again, to cancel, since logarithmic functions and inverse function, exponential functions are inverses, I want to cancel out that log base 2 to get x. I want to get the x by itself. So I'm going to make both sides of the equation a power of 2. So here's what I'm writing there. It's harder to see, but I'm going to write it this way. I'm going to rewrite it all together. 2 to the power of log base 2 of 4x is equal to 2 to the power of 5. Now what happens is this thing and this thing cancel out. You can confirm that in your calculator if you want. But you get 4x equals 2 to the 5th. Now what's 2 to the 5th? Well, that's 2 times 2 times 2 times 2 times 2. So that's 4 times 4, which is 16. 16 times 2 is 32. So 4x equals 32. And so I can divide by 4 on both sides. And then I get x is equal to 8. Don't have to round that one. That's one of them that you can do by hand. You could, you could confirm this in your calculator if you want, and please do if you feel the need to check these. Number 58. Okay, you can always check these answers. Log of x is equal to log of 2x squared minus 2. Now, this is weird. Wait, there's no base. I don't know what to do here. Oh, remember, this is really log base 10. Okay, so what I usually want to do is I want to raise both sides of this equation to the power of 10. Now, this minus 2 kind of presents a problem here, which I'm going to address. So I might be tempted to, like I did in problem 56, just make both things a power of 10, but let me just say you're going to run into a couple issues if you do that right away. So you can try it, but here's one thing you'd have to do. Again, this is if you're doing it by hand. You could always, like we're going to do in the next one, we're going to actually do these graphically. So you could always solve it graphically if you need to. And this is log base 10, this is log base 10, but I'm going to apply something I did earlier where we wrote everything as a single logarithm in a previous section. So I'm going to rewrite this as log base x minus, log base 10 of x minus log base 10 of 2x squared, and that's equal to negative 2. So all I did was I just subtracted this on both sides. Here it canceled out, and then here I just rewrote it. All right, separated subtraction. Do you remember what that is? The quotient property. This is, if I write it as a single logarithm, it's log of x over, I triggered my Siri. I didn't even touch it. That's a little creepy. All right, so log of x over 2x squared, which, by the way, you see how you can kind of cancel something there? Like one of the x's could cancel out. But anyways, that's equal to negative 2. So I get log of 1 over 2x equals negative 2. And yeah, this is log base 10. So since this is log base 10, I can now I only got a single log. I can make both the power of 10. So I get these cancel each other out right here, the 10th power and log base 10. Log base 10, 10 is the base. So 1 over 2x is equal 10 to the power of negative 2. But that means 1 over 2x is equal to, well, I know what 10 to the power of negative 2 is. 10 to the second is 100. So the power of negative 2 is 1/100th. And if you notice, I can see right now that x is going to be 50. If I'm jumping the gun here, it's like, oh, go ahead and solve this proportion. But the denominator is 2x equals 100, x is 50. So kind of neat. This one's a little more complicated than the rest because you got to apply that right as a single logarithm property, but it's still possible to do by hand. But feel free to, confirm that by graphing. It's just graphing, you have to have the right window. But these can be done without using calculators. And I'm just showing you that skill mostly because when you take the PSAT, you might, probably not, you probably won't have logarithm problems like that. They'll probably all be in the multiple choice section, and you could just kind of figure it out. But that's how you can do it without a calculator. All right, so now I'm going to do this one right here. Again, we want to find the answers, round to the nearest thousandth. That's number 59. All right. I want to get first to where there's one log before I raise something to a power. It's like, oh wait, but there's this 2. I actually have 2 options, but I'm going to do this. I want to get rid of the 2. So you divide by 2 on each side, and we get log base 3 of x is equal to, let's see, 54 divided by 27. Divided by 2 is 27. All right, you can actually use your calculator if you want, but guess what? Log base 3 of x equals 27. Ooh, wait. I think they're trying to trick us here. I know that 3 to the 3rd power is 27, but here's what this actually is, that they're trying to do a trick. They want you to put 3, but it's not. This is 3 to the 27th power gives you something. So the answer to this is actually 3 to the 27th power, which is going to be, oh gosh, this could be a huge number. But I want to confirm that just because they're doing that little trick. They're kind of making you think, oh, I see those 2 numbers. I knew 3 to the 3rd is 27. Let me show you how to check these graphically, okay? I'm going to go to y equals, oh, log base 3 of x happens to be conveniently in there. All right, and then I'm going to put 27 in here, okay? Now, if I try to graph these 2 things, all right, I'm going to go hit the graph key. Notice how it doesn't go up to 27. Watch, I'm going to fix my window. Now, I happen to know what the answer is. It's 3 to the 27th power, which is some giant number. It's, oh gosh, that number is huge. That is massive. But that is just the answer. You know what? I'm just going to leave it in exponential form. And if you want, you can confirm that. But yeah, I did that right. But the way you can tell, we can confirm that we did that right. Well, here's the thing. How do we cancel out a log base 3? We make something the power of 3. So it's like now this and this will cancel out. So x is equal to 3 to the 27th power. And if you try to do it in your calculator, 3 to the 27th power it's a very, e to the 12, that's like, you're looking at trillions there, because 9 zeros would be billions, 12 zeros would be trillions, and then, yeah, it's like 7, it's basically 7 trillion, 7,625,597,485,000, and then there's more after that. On your on-calculator computer, you can confirm that, but that's good enough for me. All right, we're almost wrapped up. We're going to solve these by actually graphing. So we could do them by hand. So we got 5 to the 2x equals 20. Let me show you how on your calculator you can solve all these things by graphing. Really, you can solve any equation by graphing, but let's put this one in here. So 5 raised to the 2x, we're going to put that in y1, and then we're going to put the other side of the equation in y2, the 20. Now you could do 5 to the 2x minus 20 equals 0 and solve the zeros, but I'm just choosing to do it this way. Now let's see if I see the intersection in here. Oh, I got bad news. I see one graph and that's it. Zoom fit is a great option though. That's zoom option 0. What's great about it is usually it will graph whatever it needs to graph to show the intersection of the 2 points in there. There's the exponential function, and then there's probably the equation y equals 0. I can look at the window and I can see that it is in fact graphing where they have an intersect. Now, it doesn't always choose the smartest window. Why is it going to 9 million? That is really, that's really ridiculous. Let me just do 0, and let me just do 25. I don't know why it chose that window, but I still could have found the intersection. Okay, but look, it's going to graph the first one. There's the exponential function, and then y equals 20 is a horizontal line. Second, calc, intersect is option 5. Mash the enter button 3 times. Boom, it's 0.93067. So I'm going to do 0.930. Since it's 67, I'm just going to write 07. I'm going to round up because I'm going to do the 10,000th just like the other one, since they said graph and round to the 10,000th. All right, 61. Okay, I'm going to graph this one as well. All right, we have, again, go to your calculator. This one I'll do a little different just to show you the other method. Instead of graphing each side individually, I'm going to move subtract 160 on both sides. I'm going to do 3 raised to the power of 7x minus 160. And then I'm going to intersect that with just y, because the other side of the equation now is x equals 0. I'm going to graph that thing right there. And as long as I can see the x-intercept, I know for sure that I've got like the windows. Watch, I'm going to do second, calc, intersect. I'm going to mash the enter button 3 times. And then boom, the intersection is 0.6599. So 0.6599. Again, what I did is I took 3 to the 7x equals 160. I subtracted 160 on both sides. This makes it a little easier to just, instead of worrying about like what your window looks like a lot, you can just make sure that you can see where it hits the x-axis, and that way you know that you have a good window. And then we're using our graphing calculator, so yeah, we're solving by graphing, still doing it. The x equals, boom, still that answer. All right, going to start to wrap this up. 62. 6 to the 3x plus 1 equals 215. Now, I really liked, it's 215. I really liked where I just had an easier time with the window. So I'm going to try doing that again. I'm going to just put 1 in the y. Instead of putting 1 in the y1 and 1 in the y2, I'm just going to put all together. I'm just going to subtract the 215 on both sides, right? So I'm subtract the 215 on both sides of the equation, and get 6 raised to the power of, this is going to be 3x plus 1. And then this time it's going to be minus 215. And then the other one's going to be just 0 there. But I'm going to go to my graph. And as long as I see my thing hit the x-axis, one thing, oh, there it goes. It hits the x-axis. Let me see if it hits the x-axis in the standard window. Zoom. Oop, it's still graphing. Zoom, standard. Let's see if I see it hit the x-axis. Yeah, it sure does. And again, I could use second calc 0 to find that, but the reason I want to use intersect is because it's like so steep that, and I have in the y2, the first curve is that, see how the first curve is the exponential function, right, where I move the 215 over, and then the other function is y equals 0, and so I intersect them, and boom, there's my thing, 0.6658. So 0.6658, that's my answer right there. All right, next one is 63. Okay, again, solving by graphing. I'm going to put into my y1, I'm going to put the left side of the equation, and I'm going to move that 0.12 over. Okay, if you notice, we're using our calculator for this. Notice how like doing it by hand kind of took less time. But you can get a picture of it with graphing still. So I'm gonna do the same thing I did. I'm gonna subtract that 0.12 on both sides. And again, I'm just gonna graph that. Second calc intersect, and then it'll find the answer for me, I'm hoping. So there's the thing. Does that even hit the x-axis? I'm curious. That it should. But second calc, option 5. I'm going to mash the enter button 3 times. Will it find an intersection? It does not find an intersection. So there's a problem with this. My window's not, like, see how it doesn't seem to go below the x-axis? So I'm going to go to my, I can do zoom fit, right? Zoom 0. Let me just see, so that we have to do the least amount of thinking. Let's just hit zoom 0, let it do our work for us. Now, see how this thing maybe goes a little further under the x-axis? I'm going to go to my window. I don't like how the y minimum is just at 0. I'm going to make the y minimum negative 10 just so that I can see the graph maybe go below this thing. Let me try it again. Second, calc, option 5, mash the intersect button, mash the enter button 3 times, and then boom, it still says no sign change. So here's what might be happening. There might just be no solution to this thing. Like it just might not have a solution because I have 0.5 to the x minus 0.12 equals 0. I'm pretty confident. I just really feel like that does have a solution. So I'm gonna keep chugging at it. Right? Again, this would be easier to do by just like calculating it probably. So, oh wait, here's why. Haha. I have a plus instead of a minus. Oh boy. So I didn't have to do any of that. Notice when I graph it, it now correctly goes below. It's going to go below the x-axis if you zoom in closer to that stage of it. If I go to window, I don't know why this thing goes so far up. Let's just do 100 here, and let's do the y minimum. Let's do negative 50 there, and yeah, you'll see this thing should hopefully go below the x-axis. Second calc, intersect, boom. Intersects the x-axis at about 3.0589. So x is approximately 3.0589. That's round to the nearest 10,000th. Last one on 6.5. Here's what we got. We got a culture of bacteria. 10 bacteria is started. The number of bacteria will double every hour. In about how many hours will there be 3 million bacteria? So here's how that works. You have your amount is equal. You take your initial, I'm going to use a capital I, sometimes use a P, and then you raise it to the power of 1 plus your percentage increase, and then that to the power of t, which is time. You could call that x if you want instead, but here's another way of looking at it. Since it doubles, what does double mean? Double means you add 100%. Well, here's the thing. That means my r is 100%. So my amount is equal to how much I started out with times 2 to the t, because it doubles every hour. So the t is going to be in terms of hours. So this is another way you could go directly here. Because it said double, you can just do 2. If it said triple, you could put a 3. So, but what's my initial? Oh, it tells me that 2. It tells me that's 10. So it's 10 times 2 to the power of t. All right, I'm choosing not to put the parentheses here. But wait, they didn't give me t. Oh, but they did give me the amount, 3 million. 3 million. So I want to solve for t. That's why I'm not given t. So let's do this. All right, you can't divide by 2. You don't do that. First, you divide by 10. So you get, this is just going to be 1 less 0. So it's going to be 3, instead of 3 million, it's going to be 300,000 is equal to 2 to the t. Well, remember, how do we solve for the variable? Well, we got 2 to the t, so here's the thing. I'm going to log both sides. Really, I should kind of put that a little more in front, but the idea is this. If I do log of 300,000 is equal to log of 2 to the t, that will help me figure this out. But why do I do logs? Well, I want to bring the exponent down. So it's log of 300,000 is equal to t times log of 2. And so now I can divide by log of 2 on both sides, and that cancels out here. Divide by log of 2 on both sides here. And if you notice, this is where the change of base formula comes from, by the way. I could have just logged base 2 300,000. So let me show you. I'm just going to do it with what I did here. And I'm going to do it just, the way we've been doing it on our, as the final answer in our calculator. Let me do log of 300,000, 1, 2, 3, 4, 5 is how many zeros I do, over log of 2. But because of the change, because this is to the the power, this is 2 to a power, I could have done this. Math, scroll up, go here, log base 2 of 3, 1, 2, 3, 4, 5, and notice how they come to the same thing. So the answer is 18.1946. So it's about 18.1946, but I like to put units. It's a word problem, so it's roughly 18 hours. All right, that is it for section 7.5.